Hello all, welcome to the data science full stack course. So far we have discussed about some of the algorithms in the supervised machine learning under regression and classification problems. Okay, today in this video we are going to discuss about the clustering problem. That is the first algorithm we want to discuss in the unsupervised machine learning algorithms, right? So I hope you recall what is the difference between unsupervised and supervised machine learning, which we have discussed in the introductory session when we have had a quite a basic understanding about what machine learning is and what are the types of machine learning. So unsupervised machine learning means when there is no supervision, there is no labels on the data, which we want to use it as a training data, but we don't have the training data as such with the labels, right? So clustering is one of the example, one of the algorithm which can be used to task some group of objects together, right? You can see this diagram here. So this gives you a quick idea about what does that mean, or why we create cluster when we don't have any features as such to work on the data set, but what we can do is we can group them based on those similar characteristics of this data, so those are grouped together. So we can say that the clustering is unsupervised classification where we don't know the classification already, right? Likewise, we have discussed in supervised machine learning, like logistic regression, we know what are the features, what all features we want to use to train the model, but here we want to segregate the based on the algorithm. We'll decide which parameters are more relevant, and those can be used to group them together. Okay, so it provides you the hidden insights. There are so many applications that, like customer segmentation or news classification. Those are some of the kind of categorizations we can make without the predefined rules or kind of a supervision. Okay, so identify the target customers for the business campaign if they want to run. So there are a couple of types of important algorithms in clustering. We have one is a centroid based clustering. We call it as a commonly named as a k-means clustering, and the second is connectivity based clustering, that is a hierarchical clustering. Okay, so the name of this algorithm is agglomerative clustering, which we will be discussing later on, but today in this session we will be focusing more on k-means clustering algorithm. Okay, so k-means is a clustering algorithm which is unsupervised machine learning. So if you look at the groups, how the groups are formed, so the objects in one group are similar to each other as maximum as possible, but the objects from the other group are different between the group 1 and 2, right? So between the group 1, so the distribution of objects are allowed to determine which objects should be grouped together. Okay, so like here you can see there are 4 groups created. We have one more simple concept we tried here, the basic concept of clustering, analysis of using 2 variables. Here the cluster 1, we can say this is the example where we discuss about high profit and high sales customers. So that means these are the customers who gives you high profit and they brings high sale to your business, right? There are some customers which can be segmented as low profit and low sales customers, so those are classified under cluster 2. So the remaining customers can be classified under cluster 3 as well. Okay, so that's the sales versus profit graph. You can see here sales, and here you can see the profit. So profit of $0, there are some negative profit making customers as well, and profit of €10 and €20, 10,000 euro, 20,000 euro, and 30,000 euro, and so on. And here it is a sale, right? How sale is happening, like 50,000 euro and 100,000 euro, and so on and so forth. Okay. The clustering algorithm, k-means, we will be discussing about this particular algorithm where k-means is a centroid based. It means that the groups are formed by getting the centroid of the group of values. It works on a Euclidean distance. We find out the distances between the other data points into your group, and then we form those groups, right? It makes clusters by finding and grouping the elements near the centroid into the same cluster, right? That's what exactly I'm trying to say. We will be grouping them together based on the centroid, right? So who is nearest to the centroid, those are grouped together. Okay, so we can there is a procedure. We can randomly select some numbers, that is k. K is a number of centroids you want to select, and those can be carried forward, right? So k value, let's say I select 2, then this is the value we have to select manually in k means. Suppose you have selected 2, so we have to find out all the values near to 2 two centroids. Then near to one centroid becomes one group of your cluster, and the values near to the second centroid becomes the second group. Okay, and the very first steps would be the calculate the distance of all the points, and then assign each data point to the centroid based on the distance, and then again calculate the centroid for those groups, and that is mean. Centroid is nothing but a mean, so calculate the mean for each cluster, and this mean will become the new centroid, and we have to repeat this process until the algorithm is converged. Okay, so here is the another example. We can see when the k value is 3, that means initially there are 3 centroids or mean data points, right? So we have to assume any one data point any 3 data points as the 3 different means. Not necessarily these data points have to be somewhere distant to each other. It can be a very first 3 data points as well, right? And automatically the algorithm will converge towards the end, and you will find proper 3 clusters end of your exercise here. So any 3 can be taken, that is randomly we choose. K value we have to choose first is 3, let's say. When you want to make 3 clusters, if you want to make 5 clusters, it is the business decision how many clusters we are looking for. But later on we can choose any 3 data points. This is something algorithm does randomly, and then we find out the nearest data points to these center values, that means these data points, and that is the Euclidean distance we calculate and club them together. So that's how you form a first 3 clusters and later on the centroid changes, because now each cluster's center value will be calculated, that is mean value is calculated, hence your centroid will move to some other data point, okay, or a new data point it becomes. So this is how 1, 2 and 3 groups are formed and now this particular centroid will have the nearest data points together, those are clubbed, and this is how we repeat the process as long as you are getting the same group of values together in each cluster. Okay, so that's how the mathematics behind, that's how it works, and we will see how we can actually implement that with the help of some exercise problem. Okay, I will take it a simple problem. Let's say numpy as np, import pandas as pd. Okay, import matplotlib as dot pyplot as plt, import cbon as sns. Okay, you may use some other libraries if you want, or later on we can import as well. So I suppose these are the values we got. I will take a simple exercise problem first. Let's make this clear how we use this particular algorithm. Okay, suppose I have some values 2, 3, 4, 10, 11, 12 and maybe 20, then 25 and 30. Okay, these are the values, right? You can see that this is how you can print. Okay, once you got this, now you choose how many clusters. I take 2 clusters. Okay, this is what the initial assumption would be, or initial requirement would be, to have 2 clusters. Okay, so 2 clusters. Okay, those many number of clusters we have to select. Now randomly select 2 data points from above data set as 2 centroids. Okay, meaning I will just select 2 values anything, right? So for example, I will select, for example, select, I'll go for, let's say, 4 and 12. Okay, there is nothing, no rule, you can select anything and you try and you'll find those clusters as you follow the rule, follow the procedure, right? So here, the moment you find this 4, the nearest values to 4, right? As I said, Euclidean distance means it will be in the mathematical space, it is represented and it will be found the distance between these two, right? Whatever data set you are working with. So in this case, it's a single dimension data. It's quite easy for us to identify who are closer to 4. Okay, obviously 2 is closer to 4, 3 is closer to 4, and 4 itself is, then 11 is, whether 11 is closer to 4 or 12, the answer is it is closer to 12, right? Hence we don't consider this here. Okay, instead I will get it into the second cluster now. So that's how we formed 2 clusters with this particular mechanism. Okay, so we got these 2 clusters. Okay, now let's find out the centroids for this. So the centroid for each of them, I will just use a formula near here somewhere. I'll just keep using this np dot mean, and I'll just paste these values to get the mean value, right? That's how we calculate. The first centroid becomes 3 and the second centroid becomes the average of these data points, right? And that's what this algorithm talks about. That's what we have just discussed in the theory. Okay, you got 2 centroids. Now these are the 2 new centroids. You have to form 2 more clusters for these 2 centroids. So 2, 3 and 4, this becomes 1. How about 10? 10 becomes part of this cluster or the other one. Okay, so the other cluster will have like 10, 11, 12, because 18 and 10, what is the difference between 18 and 10? It is 8, whereas 10 and 8, 10 and 3, the distance is 7. So 10 becomes part of your first, the K3, that means here I will make it K3. So K4 will be obviously the rest of the elements. Okay, now let's calculate the average values once again, and this time I get 4.75. okay, that is your C3 equal to 4.75. I'll round it here just for easy calculations, but definitely you will see how it converges, and you can probably go with the exact value if you are trying to solve some other problem which we will be doing it. So here also I'll round it to 20. So this is how you got centroid 3 and centroid 4. Let's form another 2 clusters using these centroids. So K4, now we will use here 2 other clusters like K4, right? No, not K4, it is K4 already here. Here you go for K5 and K6. Okay, so K4 will be the values near to 5, definitely those are the values. And now how about 11? Is it closer to 5 or closer to 20? So definitely it is 5, closer to 5, so I'll take it 11. Even 12 is closer to 5. Now then rest of the elements becomes part of your second cluster. So I make it this way. Okay, so then let's find out the centroids for this. Here I'll go for 1, 2, 3, 4 and C5 and C6. C6. Okay, for this cluster, let me find out the centroid. I'm just calculating the mean here. It is 7, fine. And for this, there is another centroid. It is 25. Okay, now let's follow the same procedure again and let's find out K6 and K7. Okay, for K6, if you see value 7, so all these values are closer to 7 than 25, and all these values are closer to 25 than 7. So you get the same, that means you get the same centroid this time. Okay, 7 equal to K7 C7 equal to 7 and C8 equal to 25. Now you do keep on doing this any number of times, you are getting only these two as the final values, hence your algorithm is now converged, and hence these are the final two clusters. You can in fact use it. Okay, so that's how the k-means works. This is the very simple exercise which demonstrate how you can actually use it, or how you can present this or calculate the two clusters. Okay, so that's how we can represent. Let's take a quick simple example to use this. This is how mathematically happens. So that's the idea behind representing this to with this particular example. This is a very basic example how in the back end how the mathematically calculation happens, and how you can actually perform the k-means clustering algorithm on your data point. I'll take another example here, np.array, and we will have, let's say, some data points. Okay, maybe we can represent into two dimension space with two data sets. What I'll do is I'll go for two values. Okay, so this way, suppose I go with a data point, let's say 1 comma, on x-axis 1 and on y-axis 2. Then on x-axis I'll take, let's say, 5, and on y-axis I'll take, let's say, 8. So we can have these 2 points. Then I'll go for, let's say, 1.5, then 8, then 1, and then 9. Okay, similarly I'll go for, let's say, 1.8 comma, I'll keep it 8 again, I'll keep it let's say 0.6, some smaller value, and then I'll go for 11. Let's say we got these two data points. Let me just plot it. I hope you recall how to use a plot here. So x comma y, let's try and see. Yeah, these are the two dimensional data points, right? The data points into two dimensions. So you can see 1 comma 2, 1 comma 2, 1 comma 2. This is the point, right? And then there is 1 comma 0.6 as well. This is the data point, and there is 1.5 comma 1.8. So this is the data point, and there are few data points which are little far here, like for example 5 comma 8, then 8 comma 8, then 9 comma 11, something of this sort. So this is how you represent your data. And now let's use sklearn, okay, library for the clustering algorithm, that is a cluster as a submodule, and we can use from this, we want to import k-means clustering. Let me see if we have. Let me see. Okay, k-means. Oh yeah, k-means is there. Okay, so k-means is there. K equal to k-means, and you provide the number of clusters. This is a very small data I want to take it to, and that's what we have discussed already, that we should know how many clusters we want to form, right? It's a business decision. For example, the example when I took the example of a cluster segmentation of your customer segmentation, or clustering your customers based on their purchase behavior, or based on their priority, based on their sales volume, or their credit points. So there are so many things. We can divide those customers on some kind number of groups, right? So based on the business need, so those groups can be formed. Okay, so we use this here in this small exercise problem. We use two clusters, and we will see how we can actually get this understand this with the help of k-means, right? So let me see, k-means centroid or cluster, no, k-mean clusters are, okay, we can do some kind of number of clusters, and let's go transform. Okay, so yeah, let's do this. We got this k-means done here. We have calculated, And what we can do with this data is maybe I have to try something here. K-means dot fit, maybe I will use x data points. Okay, actually we should form some x value here. Okay, just give me one moment here. Let me figure out how I can. Okay, k-means is just an object we have created for k-means cluster, and we got two clusters. We want to train this model with the data point, but now we have x and y. We should convert your x data using those values. I will do this manually, but you could obviously do if you want, use this pandas numpy library to see if we can add this. Okay, 5,8, then 1.5, 1.8. Oops, yeah, here. Then I'll go for 8,8. Then I'll go for 1, 0.6. Then I'll go for 9, 11. Okay, let's have this this data set, because this is going to be a data set which I will try and fit it. I want to train your model, that is a k-means model, because on this particular data the model will work the way we have tried. It will try find all the centroids for each of the set which it forms. It automatically takes the takes the random data points for first time, and then since there are very less number of data points, there are only 6. That means there are 6 points. Okay, so hence it is going to be a quick one. It will take one of them as a random point, two of them as random centroids for first time, and then it keep on getting the mean, the nearest values to the centroid, and find the mean. Again, it does the same steps to converge the algorithm and to find the two clusters, right? So let's try and fit it and see what it does. KM, it has done its work, it seems. Let me find out the cluster centers. Perfect. I think this gives us the cluster centers using this particular technique, okay, where we can actually find out the centers, and km dot labels. Okay, we get the labels as well. 1 0 1 0 1 0. That means these are the for first point it's a cluster 1, for second is cluster 0, for third is cluster 1, then it's cluster 0, this is cluster 1, and then 0. So it looks like correct, right? So this is a point which is actually here, this is the point which is actually here, this is the point which is actually somewhere here, this is the point which is actually here, this is the point which is actually somewhere here, and this is some kind of alternate values I took here. And so that's how it is clustered, labeled by 0 1 by default, and you can see how you got this whole data printed. Maybe I can try and plot it using scatter plot. You can do centroids, okay, I will have to use km dot centroid, right? So better I'll use c equal to km dot cluster centers. Okay, so now let's check the type of C. It is ND array, and if I print the C, it gets the centroids like this, right? Now plt dot scatter, and here let me see if I can find out the center value. So I want all the rows, but I want only the 0th column. That means 7.3, 1.16. That is your first point, and the second would be colon comma 1. Okay, this gives you a second point. Okay, so maybe let me plot. Oops, nothing happened. Okay, actually I will try and see plot plt dot scatter x comma y. Okay, let me try. I think there is something wrong with the centroids. Centroids km dot cluster centers and centers. Okay, okay. Actually, I should use all the rows and only a zeroth column. Okay. Yeah, good. So I could find this. These are the points, and these are the centroids. Right. I can make some different marker here. So I can use a star here just to differentiate. Sorry. Yeah. Here you can see this is a star. You can specify the size as well. It is, let's say, is equal to 100 or 120. You can think about giving a little bigger star here to differentiate your two clusters. Right. So this gives you how you can form a cluster and you know how you can actually represent that into the plots using a scatter plot. So this is about k-means clustering. We have discussed about how we can how the maths works, how k-means works, and these are the steps. I revisit this. This is where you will now connect the understanding about as per your problem. So randomly select some number k. This is not actually a random, but it is actually the business who decides how many clusters you want to have. Those many clusters you have to make, but randomly you have to select the two or any number, like the suppose k value is given by the business is 2. So randomly you have to select two such numbers from your data set, right? And those are called as the centroids now. Okay, then calculate the distances. That means from this particular two values we want to calculate all the distances, and nearest will be closed together, put together. Then assign each group. Now you got two groups, right? So the entire group have a different centroid if you calculate the mean, right? So you calculate the mean of each group, and then that mean becomes the new centroid, and then you have to once again you have to assign the points, and then distance, calculate the distance between the various points. You may get some points from the other group, but you have to calculate get the distances between each of the point, and then you find out the next nearest or the next centroid, and we have to keep on doing these steps till the time your algorithm is converged the way it is demonstrated in this diagram as well. Okay, so we can create these clusters. There are different ways how we can do using a k-means different clusters, and the procedure is same, but different clusters we can form any number of clusters based on our need. So this is about k-means clustering, the basic example, and I try to give you how it works. And the next in the next session I will try to explain you with one of the data set how we can apply the k-means clustering, and there is something called elbow method to identify the number of clusters at times if you want to find out how many clusters is the best suitable clusters for a given data set. So those things can be the additional thing which we will be discussing in the next video. Thanks for watching k-means clustering. Please practice, and see you in the next video. Thank you.